Oh dear. Maybe I should write it up there. But first we're going to answer questions about exponents. But this is today's lesson. Thank you, Sawyer. Thank you. Before we do that, do you have questions? I bet, Jonathan, you have some questions, don't you? It hurt your head. Did it take forever? Was it too much? I'm surprised no one texted me or emailed me.
I messed up my Adobe scanner.
Okay, let's look at it.
I messed up my Adobe scanner thing. I deleted it and re-downloaded it because the stuff wasn't showing up, and when I tried to do it again, I couldn't log in because of the screwed email.
Okay. Ready?
It was a bird.
I didn't. All right, which one? Give me one from your homework to work that you struggled with. 8. I heard 8 first. I'll do 5 also. All right. PM0 Q0 over 2M. I think I forgot to post a recording last night. If I ever do that, please remind me. Oh dear. My life is not together. I've been in a stressful place right now. Now that this observation's over. Oh, that's nice. Maybe you should tell the class. Did y'all hear that? Listen, tell them again. Tell them.
I didn't know he told me that. Yeah, I
didn't know you had that.
I did not know that. Thank you. Wait a minute, so you can scan it right from your phone?
The question was, if we've got those 0 exponents, does it just kind of go away? And because I'm doing nothing but multiplying here, the answer is yes. Because if you multiply by 1, that just keeps everything the same, right? So this is my thought process on this one. I mark out the 0 exponents, and I'm going to go ahead and distribute this through and make sure it goes to everybody. All right, so I got a P left up top on the bottom. I got 2, -4. M, this multiplies, -12. Q, 8. 2, 3. Q, 3. P, -9. I would clean up the bottom now. Some of you go ahead and move your negatives. It does not matter. I just like to clean it up before I start. I got a P on the top. I got -2 and 3 2's, which leaves me with, what's -4 plus 3? -1, right? Everybody with me? Are y'all following? M, I've got M, -12. How many? M, N, O, P, P's, -9. And then Q's, 8 and 3 gives me 11. Now I'm going to move everybody up that goes up. If you went ahead and subtracted those P's, that's okay too. It looks like this guy goes up, this guy goes up, this guy goes up. So I have P. That P was already there, right? What's wrong, Caitlin? It's all you are multiplying. You're still multiplying. This is multiplying, but this is multiplying, and this is multiplying, and this is multiplying. Just because the sign's not there, you're still multiplying. I think you're thinking whenever there's pluses or minuses, like whenever you get into foiling and stuff. Is that what you're talking about? Tell me when you got here, did you distribute these exponents to each of them? Okay, so you got something like this. At this point, you can drop the parentheses. And you can drop the parentheses because here I'm multiplying, but inside I'm only multiplying. And as long as you're only multiplying or dividing inside, there's no addition, subtraction, you can just drop them off. It's still multiplying, yeah. It does. Okay. All right. Now, I've got this fraction, right? I've got 2 M12 P9 Q11. Yes? What's on the bottom? Oh, just kidding. Just kidding, yeah. Look, I did that to make sure y'all were paying attention. Thank you for paying attention. Y'all did a good job. All right, now I'm going to combine what goes together. So I've got 2 P10 M12 over Q11. Because I got P9 and P1. Oh, you're right. It probably should be MP.
What I did is I don't think something like that.
It doesn't matter.
Over 8. Same thing. Does it matter? Whenever I like I moved the Q11 up. Wait, so it does matter.
Don't move the Q11 up because it's positive. I went to do that too.
Let's hold that up. Okay. So I cut the ones there and then just
That's
do
fine.
one
It's multiplied.
square and then one. Like right.
It's still the same
added them
thing.
together.
Just make sure there's a multiple.
No, but I left a big one. Like
That's fine, but what's 2 times 1?
so
So,
why did you do that? That doesn't have an X in it and it's not the same thing.
but it doesn't matter. Anytime you have a 1 that you're multiplying by, you can just drop it. Yeah. All right. I'll try not to. I'll try not to. I write the line in it, yeah. But,
When I work it, I do.
yeah. 5.
My twos look like.
She loves to write her math in pen. I never do math in pen. Yeah. I make enough mistakes that I have to do it in pencil. All right.
Oh.
All right, several things I can do here. I can combine what goes together. I think looking at this, I think I'll do, guys, listen. I think I'll put the H's together up top and I'll go ahead and distribute this through all in one go. Now, when I'm working with these complicated fractions, I will generally write the whole fraction bar and then I'll just start putting things where they go. So this is 2. I've got H negative 4, J, K negative 1, JK. 2 squared, H squared, J squared, K 4. Where? Oh no, so it's negative, 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 negative. All right, let's move some things around. Down, down. And everybody on the bottom is going to come up. Okay.
Yep, y'all heard
it. That's it, I mean. All right, 2 and the J stays up top. Now coming up with it is going to be 2 squared, H squared, J squared, and K to the 4th. And coming down, nothing's left in the bottom, but I got an H4K1. Yep. All right. Up top, I got 2 to the 3rd. I got H to the 2nd. I got J to the 3rd. Guys, it's getting harder and harder to talk over you as you get louder and louder. K to the 1st. I hope what you are doing is correcting your work as we go. So now I subtract. So I got 2 to the 3rd. Now, some of you might have found the little shortcut here where if you subtract negative, they end up in the bottom, so you don't have to take 2 steps to do it. In other words, I always go, okay, I'm just going to subtract the biggest minus the smallest, so 4 minus 2, and put it where there was more to start with. So it's going to be 4 minus 2 is 2, and there were more in the, it's going to have to go, it saves you a step, is what it does. 3 J's up top. I got 4 K's up top, 1 K in the bottom, leaves me how many K's where? 3's up top. If you change the 2 to the third to 8, that's fine too. It just doesn't matter. Sometimes whenever we're only using spaces of 2 like that, we just leave it that way, but it doesn't matter. What else? What else? Once. Twice. No. We'll probably add, subtract, and multiply today. We might not get to divide. We probably will get to divide.
Is this a whole different thing?
This is a whole nother thing. Alright, before I talk to you about polynomial operations, let me talk to you about polynomials. Guys, if you're talking, don't.
What is it?
You're so right, Jonathan. You're so right. All right. Wait, but before you can do operations, I have to show you classifications. Big heading is polynomial operations. This is a, yes, that's perfect, Riley Grace. OPERATIONS. All right. Polynomials. We've done quadratics. Now we're going to do polynomials. Tell me what polynomial means. Many. Poly means many, right? This is one, I'm going to say greater than or equal to one term is a polynomial, but these are special terms. For these terms, the exponents on the variable are positive whole numbers. Other than that, I can pretty much add any terms together. I guess I should ask you, what's a term? A chunk? A chunk of what? A chunk of the equation. It's the piece that's added or subtracted together, okay? So you can have, this is where I've got coefficients, variables, and I can have exponents on that variable. So whenever I have a quadratic, think back to quadratics, what's the most number of terms I can have in a quadratic equation? Let's rewind. Give me an example of a quadratic equation. Quadratic.
Fx equals x plus, or parentheses, x plus 4 squared.
Plus 4x equals 8.
Okay. This is an example of a quadratic equation, okay? This is quadratic. Is it indeed a polynomial also, though? Yes, because it's got greater than or equal to one term. The terms here, this is a term, this is a term, this is a term. The terms are added or subtracted. Now, just to be a polynomial, I'm only looking that the exponents are positive whole numbers, but the exponents that are hooked to the variable. So I'm talking about 2, 1, and then there's not 1 here, but technically there's a 0 there. Okay, those are also, it checks the box. So yes, this is a quadratic polynomial. Now, this is being a little redundant to call it a quadratic polynomial, so I'm going to teach you some naming techniques here with it. All right, when we look at these, we're going to look at them in standard form. What do I mean by standard form?
Like how it is 8x squared.
Okay, but what are you doing there? Ordering them how? Biggest exponent to smallest. Stranger things have happened. All right.
Oh, what is that?
Is that a polynomial? What it is, you're right, it's an irrational number, but what are my qualifications to be a polynomial? Exponents on the variable are positive whole numbers. Positive whole number? Positive whole number. I'm not in standard form, but could I still be a polynomial is what I'm asking.
Symbol.
What? Pi?
Oh.
Y'all haven't done pi before? How's yours look like? Yes, look. Yes. How about here? Yes. How about here? There's not one there. But there's like a 0. Yes, this is a polynomial. It's made up of terms that have degrees of positive whole numbers, okay? Okay. All right. Now, is it in standard form? No, put it in standard form.
Okay, you're the one that always does it. I do it, get mad at me.
Is it your boyfriend now? Oh no! He's just giving it a little time. He don't want to look too anxious. Okay. All right. Standard form, yes. Now, oh. What? It's a constant. It doesn't have that x variable. Yeah. All right. So good question, though. I have several things going on, guys. Y'all need to pay attention. This is the foundation of the unit, and you need to get it. The pi on the end is what we call a constant. Even though technically it is a variable, it is a constant variable. It always represents the same value. 3.1415926. I don't know any past that. That's not right. Nope. Okay. Yes, I will. All right. Shh. Guys, I need y'all with me. Yeah. It's the exponent you're looking at, not the coefficient. Yeah. All right. We'll see. All right. Oh my gosh. Okay. We classify polynomials by two things. We classify polynomials by their leading coefficient. What on what? We put it in standard form. That's all we've done. That was another example. So I said, is this a polynomial? Yes or no? And y'all said, yes, this is a polynomial. So since it was a polynomial, I said, okay, put it in standard form. That's when we got to the blue down there. You with me? Okay. Then we would say no. Like, for instance, I'm going to come back to this now, y'all. That's these little checks. Yes. And whole numbers. All right, look. If I had 3x to the 1/2 plus 6x squared minus 5, that is not a polynomial. Why is it not a polynomial?
It's less than 1.
That's not a whole number. I'm not asking is it in standard form. I'm asking is it a polynomial? Could I put it in standard form? And the terms that you have, yes. There's two requirements, greater than or equal to one term, and the exponents have to be, on the variables, have to be positive whole numbers. Okay? Now, when you, yeah. It's a 0. It's still there. So technically, y equals 5 is a polynomial because I could say x to the 0. Johnson. It is a monomial, yes. We're going to talk about that in just a second. All right. All right, guys, back to my example here. The negative 8x cubed. We classify polynomials, and this is very important. You'll have to do this on your test and on your quiz. We classify polynomials by their leading coefficient. So before we do that, what is a coefficient? There's lots of vocabulary. A coefficient is a number in front, we'll say in front of multiplied to the variable, okay? So if I look at the term, we'll just 5x squared, what's the coefficient? 5. 5 would be the coefficient. Yes, yes. Now, when I say the leading coefficient, yeah. A coefficient is the number in front of the variable. A term is the coefficient and the variable all put together. So 5x squared is a term, but 5 is the coefficient. See the difference? Okay. Now, the leading coefficient is the coefficient that leads the equation when I'm in standard form. So it leads when in standard form. Now, you could also say it's hooked to the biggest exponent. So if I give you a polynomial, could you identify the leading coefficient? Could you put it in standard form? Could you identify the constant? What's the constant? The one that does not have an x on it. What if there's not a constant there? 0, right? Okay, 0. All right. Now, I said we classify a polynomial 2 ways. One way is by its leading coefficient. So this is important. I'll put a number 1 by it. The second thing we classify it by is by its degree. Does anybody know what a degree of a polynomial is? What? It's the biggest exponent. Okay, so that term that's in front of the polynomial, whenever you put it in standard form, is very, very, very important. It holds your degree and it holds your leading coefficient. Okay, so looking at that one that I keep referencing, that negative 8x cubed, this one. Oh, what? If this is my polynomial, we've already put it in standard form. We've already identified that the constant is negative 5. What is the leading coefficient? Negative 8. Just the number, no variable. Okay. The degree would be biggest exponent. Okay, is everybody with me? Actually, I lied. It's not the leading coefficient. I'm thinking in behavior. We classify by the degree. I'm going to change my number 1. And then the number of terms. But you have to know leading coefficient too. Just change your number one, scratch out number one, and put number one down here, number of terms. I know, y'all are so OCD, this is going to bug the snot out of you. We you don't even take notes. We classify the polynomial by its number of terms and its degree. How many terms does this yellow one have? 4. I think you have. We're going to name our polynomials. I'm going to give you a chart based on the degree in the polynomial, and then we're going to name some polynomials. Y'all ready? We're definitely not getting through everything today. No. Yes. It's only based on the number. Yes, because it have 3 instead of 4. Yes. You're going to see that you already know these probably, or you've at least heard of them. Here we go. I'm giving you the definitions, and because technically you've had them in Algebra 1, I'm just kind of running through. All right, we'll do number of terms first. It's the easiest. I'm going to give you a little chart. Can you have 0 terms?
Yes.
Yeah.
No, silly gooses, you wouldn't have anything then, right? If I have 1 term and 1 term only, Lily Mae already told y'all what that's called. What's it called? Edward, say it again. Monomial. Did you, Riley Grace? Thank you. That was a good job. That was a good job. Good job. Good job, Ray. Good job. Good job. Give yourself a pat on the back if you said monomial. Look at all these pats on the back going on. Okay. Two terms.
Those
Binomial. Look at their worth. You beat me to the punch. You are on it. If I have more than 4, I just call it a polynomial. Remember, poly means many, but technically all of these are polynomials, okay? Because a polynomial only has to have 1 or more. Yeah. No. Yes. Now I told you we also classify it by its degree. This is when we get fun. So every one will have 2 names, a first name and a last name. Okay. This is actually the last name. I'm just testing your flexibility here. Can you have a degree of 0? Yes. Yes. If I have a degree of 0, I'm looking at something like y equals, what did you say, pi? Y equals pi. Y equals 2. Y equals, it's a constant, right? That's why we call it a constant. That's exactly right. A constant monomial. Good job. Could you have a constant binomial?
Yes.
No. Give me an example. Give me an example of a constant binomial.
2 plus 2.
But that's 4. I think you're right, Sawyer.
There's not one.
There's not one. All right. How about 1? Any ideas what the name of a degree of 1 would be? What'd you say? You know this one.
Super duper uno constant.
It starts with an L.
Linear.
Linear. If you don't get the next one, you don't get a pat on the back. I'm not even telling. Yes. Who said it? Quadratic. What did you say, Worth? What did he say, Ryan? What did he say? I appreciate your effort, though, really. But it's quadratic. He said, I wish I did. All right, how about a degree of 3? Cubic. Oh, no, you're fixing to really get confused. What's 4?
Quad.
We've already used quad. It's qua something, but qua what? Think about a quarter. How many quarters does it take to make $1? Quarters, quartic. We go up to 5. You won't guess this one.
Quintric.
Close. You're 1 letter off.
I said quintic.
Above here, we'll just say n. Yes. Whatever number it is bigger than 5, we just call it an nth degree polynomial. 6th degree polynomial. You replace the n with 6. 6th. Yes. Yeah. 6th and an nth. Okay, let's do.
Like 8th degree.
Yes.
So why do you write nth degree polynomial? N stands for number.
Yeah, n stands for number.
N stands for number on the left, and then you fill in the number on the right.
So if it was a 9, then I'd say that's a 9th degree polynomial.
Could it be a 9th degree binomial?
Yes.
I'm not gonna write polynomial.
Okay, so don't. It just means you can put any number in n.
I feel like it's part of
Sawyer, give me an example of a cubic binomial. Cubic binomial is what we're looking for. Do you concede or you gotta guess? No, you can do this. What does cubic mean? This means a degree of 3. Binomial means what? 2 terms. Give me an example of a cubic binomial. Yes. Fine. That's actually, yes. Yes.
All right, Lillian's turn.
Worth.
Wait, do you have to square on the 2?
You don't have to now. You can just have 2. You ready? Let me spell it right. Give me an example of a linear monomial. Almost. Going the wrong way there, buddy. Monomial, 1 term. Linear means the degree is what? Degree of 1 with only 1 term. Missing something. Somebody help him out. X. 1x. 5x. 2/3 x. Just the x. 7's constant, not linear. 7x would work.
Wait, Missy, why do you have to keep? Like, why can't you like?
Because it's linear, so it's got to have a power of 1. The biggest exponent's got to be 1. If it has an x on it, yes, but if it's a constant, it's got a power of 0. What? Kaylin. Oh, don't look so scared.
What is the thing?
Classify the polynomial. You can do this. You can do it. Do it by the degree first. What's the degree? 5. So what is it? What's his first name? Quintic. Now what's his last name? That's exactly right. A quintic trinomial. Y'all give her a hand. She didn't want to do it, and she did a great job.
But you did it anyways because you were the one that really carried the votes.
Huh?
It's been 35.
Brother, we hadn't even done what we were supposed to. We were just
Can I do
classifying.
it? Can I do one? Dave, you are the vote.
3 pieces. You ready, Max?
I didn't know that could be a volume.
Yeah. Last one. This one's for Max.
Got it, guys. Don't worry.
All right, Max. Give me its first and last name. Okay.
All right.
Huh?
Turn that. Go. Hold on.
Give him a minute. Give him a minute. I got you, Max. It's okay. I'm gonna hold them off of you.
All right.
Here we go. Drum roll. Brrr.
Polynomial.
Yes. Yes. Give him a hand. Give him a hand. Give him a hand. A cubic polynomial. How or ow? Tell him how, Max.
Because the biggest exponent is 3, so it's cubic. And there's 4 terms, so it's polynomial.
All right. Why are we doing all this? Well, I'm glad you asked. Now we get to the operations. One more example for you.
No, not for me.
Don't worry, there's more of them to come.
I'm already on the third page. Yeah.
Brother. What, do you have a little composition book or something? No, she's got regular size notebook paper. We're not going to spend long on this because we've technically done it. This is not much more than combining like terms. So before we combine like terms, guys, tell me what a like term is. Define like term for me. There you go. Same variable. Yeah. Yeah. Is it Bluey? Yes. Yeah. Same variable, same exponent, okay? The coefficients can be the same or they can be different. It doesn't matter. All right. All we're doing is going through and combining like terms. When we do, this is when we add, we're combining like terms. When it's subtraction, remember subtraction and addition, they're the same thing. I'm just adding a negative, okay? So technically, it's the same thing here. So let me show you an example. We're going to run through one example of each, and then we're going to be done with that and do the multiply. Give you a minute to catch up. Let me tell you a joke. What did Mama Tomato say to Baby Tomato? They won't.
Catch. What did the right eye say?
You get it?
to the
Because
left eye?
stomp. You know, he stomped.
What did the right eye say? to the left
Wait, the right eye say to the left eye.
eye? There's something that smells in
I got it. I got it.
I don't care about your question.
All right, listen. The easiest thing to do with these, is to start with your biggest exponent and work your way down. That way you are in standard form when you're done. So it's 2 steps combined into one, right? So in other words, I look through both of these parentheses and I say, okay, my biggest exponent in either one is what? 2. So that's the one I'm going to start with. So I will generally circle them. 3x squared. Do I have another? Notice this is plus in the middle. Always pay special attention to your operations in the middle, because a lot of times those operations, when they change, you start wanting to do things that aren't really there. So you don't want to multiply when you're supposed to be adding. You may have done pre-algebra. All right, 3x squared and 4 and oh, Stacy. Gives you, Brother Grace, what do you get?
I got 4x squared plus 6x times 9.
4x squared, then I've got 11x and negative 5x, which gives you, you're right, 6x. And then I have 4 and negative 13, which is negative 9. Am I in standard form?
Yes.
Yes. What's my constant? Negative 9. What's the leading coefficient? 4. What's its first and last name? Quadratic trinomial. It is. All right, that's adding. I'm not going to spend any more time on adding because adding's easy and like some of you said. Let's do subtracting. I'm going to do subtracting and multiplying. I'll probably save divide. I don't know, dividing's pretty easy. Listen. Same amount of room for subtracting that you needed for addition. Yeah, it is, because we're just going to divide by a monomial today. Now, I'm not in standard form, but that's okay, because I'm going to make sure I'm in standard form when I am finished. Be very careful, because I'm subtracting everything in the parentheses that follows the subtraction sign. So if you are a distribute kind of person, and you want to distribute this negative through to everything, you certainly may. In other words, you can do same, change, and then I say change everything so you don't get confused, okay? And then what's in blue? The purple is what I change. Keep, change, change, but you change everything that follows the subtraction sign. So it's up to you if you want to do that. Some people look and they just like to go, okay, 4y squared minus positive 2y squared, and you want to do it like that. I find it easier when I'm working with polynomials just to go through and change the sign so that I've turned it into an addition problem. So you do same. You change this to an addition sign, but whenever you change this, you have to change everything in this parenthesis. Okay? All right. All right, so let's search through both of these for the biggest exponent you see. What is it? The cubic, right? So I'm going to take this y cubed. It's positive, and I'm going to throw it up front. Now, do I have any in, this is the way I do it now because it's not in standard form, which makes it a little bit harder. So I've got the third power. Do I have any powers of 2? I'm done with this one. Yes, I've got a 4y squared and a negative 2y squared, which is going to give me positive 2y squared. All right, my next one down from that, that's 3 and 2. I'm done with these. I'm going to mark them out. I tend to mark them as I go because otherwise, whenever you get into some of these big, long polynomials or you're adding 4 and 5 polynomials together, it'll get confusing. Y's. So I've got a y here and 5y here. So how many y's? 6y. -3 and -1 is -4. That's my example. I did that one. I told them to give them a title. That was my title. Okay. That is a cubic polynomial. You're exactly right. Good job. All right, let's multiply. I'm ready. What? Thank you.
I heard you take a picture and send it to me.
Multiply polynomials. This you probably learned as FOIL. I don't like FOIL because FOIL only works when it's 2 binomials multiplied together. So I reference FOIL a lot because that's how y'all learned it and you know what I'm talking about whenever I say FOIL, but I never FOIL. I always distribute. And if you learn multiplication of polynomials by distribution, you never have to learn another way. It works with any 2 polynomials that you have. So for example, if I have x minus 7 times x squared plus 2x plus 1. I am going to start with the first term in the first parentheses, and I am going to circle it. And it distributes to everything in the second parentheses. Okay? So, x, bless you, x times x squared is what? X cubed. Remember those exponent properties? X times 2x and x times 1, 1x or x, right? Same thing. Okay, I'm done with this guy. I marked him out. Now I'm going to circle the next guy. The next guy is -7. And he is going to multiply through to everything in the second parenthesis. So -7 times x squared. That's where you tell me what it is. -7x squared. -7 times 2x. And -7 times 1. Now gather your like terms together. X to the third. How many squareds do I have? 2 and -7 give me -5. 1 and -14 -7. Cubic polynomial. That's exactly right. You'll be naming every one as we go. This is a cubic polynomial. What is its leading coefficient? 1. What's its constant? -7. All right. If you had 3 polynomials that you were multiplying through, like if I had x minus 7 times x plus 1 times x minus 5, you can only do 2 at a time, okay? So you would do 2, you would get this answer, so it would look something like this, and then you would multiply it to the last one, okay? You can never multiply more than 2 at a time. So if you need to write that in your notes, write that, never multiply more than 2 at a time. The other thing I need to tell you before I show you this little division and I'll be done, is if you have something like this, what do? You got to spread it out. You're exactly right. You cannot, never, ever, 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 ever. That's right. We love puppies in here. We don't want to kill them. You have to write it. This tells you how many times to write it. Yes. You can never multiply more than 2 together at a time. In other words, don't get on this one and bounce it here and here. You can't do that. You would have to just simplify these 2, get an answer, and then multiply it to the x minus 5. All right, last thing, I promise this one's quick and easy. And that is division, and it's easy because we're only dividing by a monomial. Starting in a couple days, we will be doing some serious division. This thought process is based on the fraction property of if you are this is only when we divide by monomial. If you are dividing, not today, no. Yeah, we're gonna do we'll do polynomial long division real soon. It's so much fun. Okay. Yeah. But you haven't, I know, and I'm gonna run you an example. I teach it like you learn in second grade. All right, so whenever I do this, whenever I'm adding or subtracting in the top, right, I can split this up into two fractions, and that's the concept that I'm gonna use here to simplify these. So, for example, so I guess I should say split up and simplify each piece on its own. How do we do that? So, for example, if this is my polynomial, am I dividing by a monomial? Yep, I got a trinomial divided by a monomial. So what I'm going to do is I'm going to split it up, okay? 20x cubed over 4x. Everybody gets this denominator. It's kind of like, remember whenever you added fractions back, whenever you learned to add fractions, you had to have that common denominator? And once it had the common denominator, you put all the tops together over the same bottom. Remember that? You're undoing that right now is what you're doing. I was showing you that property, how that property works. So a lot of people don't realize how that property exists. I don't know. It gets lost in your brain somewhere. We're basically undoing addition. This is, you probably are used to doing something like this, where if you got a common denominator, you just combine the tops over that same denominator. But we're going the backwards on that. Yeah. All right, so now we're going to simplify each one on its own, okay? So we are going to divide the leading coefficients and then subtract the exponents because we can, because that's what we did yesterday with our properties of exponents. So in other words, 20 divided by 4 is 5. 3 minus 1 is x squared. Minus, well, these 4's cancel. I got 2x up top, 1x on the bottom, so just x minus, these x's cancel, 2. 8 divided by 4 is 2.